part of this geometric proof process, we're going to explore some theorems. And so with theorems, a theorem is any statement that you can prove. Okay, and so we have some theorems that have already been proven and we can use them. Sometimes we will abbreviate theorem THM. Okay, so if you see that in your book, that's what that means. 2.6.1, linear pair theorem. If two angles form a linear pair, then they are supplementary. This is basic. So angles 1 and 2, they form a linear pair. That means they're supplementary. They add up to 180. Okay, good to go. If two angles are supplementary to the same angle or to two congruent angles, then the two angles are congruent. Pretty straightforward. It means that we're substituting one in for the other. Okay, and so when we're doing this, these are going to be some more of the reasons that we can put in these geometric proofs. Here's our geometric proof outline. Notice it's got the statements and the reasons in 2 columns. Okay? When we're talking about these things, here's how we're going to use this outline to help us. Okay? The statements are going to go like this. Okay? And this is what we say. Okay? What we say goes on the left side. And this is going to be a corresponding list of things. And these are going to be why. And this is going to be why we can say it. Okay? This is called a 2-column proof. Okay, that's called the 2-column proof because there's 2 columns, the statements and the reasons. Okay, and so this is the general outline with what we're going to be doing. We've already seen a couple of these maybe in the homework, but now we're going to try to look at what it actually means to have these things. Okay, and so the given is up here. 1 and 2 form a linear pair. We want to prove that 1 and 2 are supplementary. So we're going to go through this logically as we follow it down. We look at 1 and it says 1 and 2 form a linear pair. Well, that's given. So see, this goes with this part. So ray BA and ray BC form a line. Well, that's the definition of a linear pair. Because if we draw this angle here, okay, we're going to draw this picture. Angles 1 and 2 form a linear pair. Well, BA and BC form a line. Well, it's the definition of a linear pair because they form a line. Okay? ABC is equal to 180. Well, that's the definition of a straight angle because this is a straight angle. ABC is a straight angle. Okay? And so when we look down in number 4, we notice that the reason is the angle addition postulate. Well, where are we trying to go? We are trying eventually to say something about 1 and 2. And so if we put the angle addition postulate and we work backward from 1 and 2, we are going to need to incorporate something about 1 and 2. And so what I'm going to say is the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle ABC. Why did I choose this? Of all the things I could possibly say, why did I choose this? I had to look logically at what exactly was going on. I knew I was going to need 1 and 2. Okay, I knew I was going to need this part. And so I chose to put it in right here. And because I was using the angle addition postulate, I knew 2 angles had to add up to 1 angle. Now, instead of saying ABC, I'm going to tie these two together here. ABC is 180, so I'm going to say measure of angle 1 plus measure of angle 2 is equal to 180. I substituted in there. You see how that works? And then angles 1 and 2 are supplementary. It's a process, guys. It's just something that we have to go through systematically. That's all it is. It's a system. It looks like foreign language right now, but trust me, it's going to get better. You can do this. We're thinking logically. We're using the steps given later in order to prove what we're going back to. And so in 6, when we say angles 1 and 2 are supplementary, that's going to be the definition of congruent angles. Okay? Sorry, that's not the definition of congruent angles. I've got the wrong one. The reason that we can say what we say is going to be based on the line below. Okay, so angle 1 and angle 2 are supplementary. Why can we say that? Well, what are we looking at? We're looking at the definition of supplementary angles. Okay, definition of supplementary angles means they add up to 180. That's tied to this, and it's also tied to this. Okay, and so that's the process. Go ahead and try this one on your own. I'm going to go through it here without stopping, but you can pause it and try to do it on your own if you would like. So, my givens. Okay, what is given? Well, I'm given the fact that angle 1 and 2 are supplementary, and angle 2 and 3 are supplementary. So angle 1 and angle 2, as well as angle 2 and angle 3, are supplementary. That's given, okay? So I can cross that off my list if I'd like, because I've already used that. Now, measure of angle 1 plus measure of angle 2 is equal to 180. Measure of angle 2 plus measure of angle 3 is 180. That's the definition, guys. That's what it means to have supplementary angles. And so what I'm going to do in my next line is I am going to say, if I'm substituting, what can I possibly substitute? Okay? So I'm going to substitute. Let's look at what happens here. I'm going to substitute measure of angle 1 okay? I'm setting those equal to each other now. Okay? Because when I do that, I'm going to say measure of angle 1 plus measure of angle 2 is equal to measure of angle 2 plus measure of angle 3. They're both equal to 180, so I set them equal to the same thing. Now, measure of angle 2 is equal to measure of angle 2. That's reflexive property. Measure of angle 1 is equal to measure of angle 3. How is this related to the previous lines? How do I go from here to here? I'm going to take away the angle 1. Sorry. I'm going to take away the angle 2 from either side to be left with this line. And so if I subtract the same thing from both sides, that's called the subtraction property of equality. Okay? I subtracted the same thing from both sides. So, if the measure of angle 1 is equal to the measure of angle 3, and I'm going to use the definition of congruent angles, I'm going to say, which is what I want to prove. Okay? The last line is always going to be my proof, because after that I'm done. I know it's confusing, guys, but stick with it. Stick with it. It's going to be worth it. Here's 2 more theorems, and then we're about done. Okay? The right angle congruence theorem. All right angles are congruent. Well, if they're all 90, then they're all congruent. The congruent complements theorem. If 2 angles are complementary to the same angles, or 2 congruent angles, then the 2 angles are congruent. So if 2 things are congruent to the same thing, and they're complementary with something else, they're congruent. Okay? That's part 2. That's part 2, guys. Stay tuned for part 3. It's going to be an exploration of geometric proofs forming our own. But that's the second part. We'll see you tomorrow.